Welcome. From this lecture, we are starting a new series of lectures on replacement decision in the subject operations research. By the term replacement decision, we mean to take decision whether an asset should be replaced or not, or at the end of which period or which year, more specifically, we should replace an asset. Now, I am not going to discuss any theoretical aspect of the chapter. I suggest you to go through the theoretical background of the chapter from a good reference book. We are mostly going to cover the calculation or analytical part of the decision, because that will make the lectures more interesting, and most of the students face difficulties in this kind of part covering calculation and analysis. Now, first of all, the chapter I have divided into three parts. The first part is mainly where we ignore the time value of money. We are not going to consider the time value of money. Second part will be where we are going to consider the time value of money, and third part is going to be for group replacement. In first two parts we are going to discuss the replacement policy or policies for a single high value asset, replacement of item, the efficiency of which determines with time. So a machinery, an equipment or a plant or anything, the asset is single, only one asset is there, the cost of which is comparatively higher, but the efficiency of that kind of asset deteriorates with time. So with the passing the time, the efficiency deteriorates, and that's why we have to consider a particular point of time after which we should not use the asset. We should not continue using the asset, because financially it will not be viable. So first of all, we are going to discuss the replacement of items, the efficiency of which deteriorates with time. And another feature of the same type of asset is the policy for the items, the running cost of which increases with time. See, there are two main characteristics. The efficiency decreases, deteriorates with time, efficiency of asset. On the other hand, we have to incur running cost, including maintenance cost, to continue the use of the asset. That running cost increases with time. So the efficiency decreases and running cost increases. Now, we are well aware that we are going to ignore time value of money for few cases. The case we are going to discuss is, there is a machine in a factory. The original cost, including installation charges, of which was rupees 24,400. Its scrap value, rather constant scrap value, is 400. At any moment of time after installation, if we demolish and sell out the scrap of the machine, only rupees 400 will be recovered. And other information. These two columns are actually other information. All these columns are part of solution. This in the examination, in your question paper, you will have this kind of information. Okay, well defined question will be there, but the important things are cost, scrap value. For so many years the data will be there. It is upon the paper setter. But the another important thing is running cost, which increases with passing the time. Okay. In this case, the running cost of the machine for the first year is only rupees 400, because the machine is new. It is on the peak of its efficiency. So there will be very low running and maintenance cost in the very first year. In the second year, it increases, goes to 1000. And see, with passing the time, the running cost increases in number of times from 400 in the first year to 8000 in the 8th year. So with time, the running cost increases. Now, how to determine a specific period at the end of which we should replace this asset? At the time of installation or at the time of purchase or immediately after installing the asset, we are going for this analysis. Keep this thing in your mind. Now what to do? Very simple thing is there. Very easy arithmetic calculations are there. First of all, this column is the first column of the answer. But with answer, we need to write these two things from, say, copying from the question. The third column is cumulative running cost. Cumulative running cost is something like cumulative frequency. 400 in the first year, but in the second year it will be 400 plus 1000, 1400. In the third year, 1400 plus 1600, 3000 and so on. Now to the cumulative running cost, we will add the depreciation cost. What is the depreciation cost? It is cost minus scrap value. In this case, cost is 24,400, scrap value is constant 400. So depreciation cost is going to be remain constant for all the span of time, rupees 20,000. Yes, rather rupees 24,000. Sorry. Now, summation of these two is total cost of using the machine. If the firm uses this machine, the total cost will be like this. Total cost means total cost of the whole period, right from the installation to the point of time we are considering. And if we divide this total cost by the respective number of years, the result will be average annual cost. Now we are going to solve this problem, and everything I will explain together with the process of solution. Now in the first year, the cumulative remains rather equal to the annual cost. Depreciation cost in this particular case is constant. Cost minus scrap value, 24,400 minus 400, that means 24,000. Now summation of these two is 24,400. At this stage, we have used, this is the end of the year. At the end of the year, the statistics will be like this. If we use this particular machine for first whole year, the total cost will be 24,400. I am sorry, this should be summation of these two, 24,400. This 24,400 is not this one. This is made up of depreciation cost 24,000 and running cost 400 for the first year. Now we have used the machine for only 1 year. So if we divide it by 1 year, that will be 24,400. This is called in average total cost. If we use the machine for 1 year, the average total cost comes to 24,400. Now second year. 400 plus 1000, it will be 1400. The depreciation cost remains constant because of constant scrap value. So now it will be 1400 plus 24,000, 25,400. So the total cost of using this machine for 2 full years comes to 25,400. Now we have used the machine for 2 years. So we have to divide this total cost by 2 years. So it will be 12,700. It will be 12,700. Okay. See the dramatic change. The average annual cost is approximately or say near to half. Why? In this case, the whole total cost is for 1 year only. But in this case, the whole total cost is divided by into 2 years. So the average cost has dramatically decreased. Now, third year, 1400 plus 1600. So cumulative running cost 3000. It is not necessary to show this plus sign every time. Yes, constant depreciation cost in this case, it is constant because of constant scrap value. 3 plus 24, it is 27,000. Now, what the situation exactly is? 27,000 total cost is there because now we have used the machine for 3 years. So, average annual or rather average total cost for 1 year comes to rupees 9,000. See, it is decreasing because every year now we have to incur only running cost out of pocket. This cost is distributed among more and more number of units. Yes, that's why the average total cost decreases dramatically. Now in the fourth year, 3000 plus 2400, total running cost for 4 years is 5400. Again, constant depreciation cost because of constant scrap value is 24,400. The summation of these two, 29,400, and now we need to divide it by 4. 29,400 divided by 4. What will happen? 7,350. Since the total cost is divided among more and more number of units, the average total cost decreases dramatically. 3,600 will be added to 5,400, it is 9,000, plus depreciation cost constant, 24 plus 9, 33,000 divided by 5. It is 6,600. Till it decreases, continue the analysis. Now 9,000 plus 5,000, cumulative running cost or total running cost for using the machine for 6 years comes to 14,000 plus constant depreciation cost 24 plus 14, 38,000 total cost divided by 6. 36,000 divided by 6 is 6,000 and remaining 2,000 divided by 6 is 3,333. So it comes to 6,333 like this. Okay, now see the important thing. If we use the machine for 6 years, the average total cost per annum comes to 6,333. See. Now, for the 7th year, the annual running cost comes to 6,400, which is greater than average total cost of using the machine for 6 years. That means this is the point of time where we should stop using the machine and we should replace the machine. But let me complete the table. Yes, we are going to make, say, now 14 plus 6, 20,400 plus 24,000 will be 44,400 divided by 7. Okay. Now 42,000 divided by 7 will be 6,000 and 2,400 divided by 7 will be something approximately let me calculate it because I have not prepared the solution. I have started it as it is with me. It will be 44,400 divided by 7, so it comes to 6,342, slightly more than that. But the important thing is it has started to increase. Again, the last year, rather 8th year, 20 plus 8, 28,400 plus 24,000. Total is 52,400, and now we have used the machine for 8 years. So 52,400 divided by 8, it comes to 6,550. 6,550. See the main thing. The average total cost has started to increase from the 7th year. In other words, the lowest average total cost is at the end of the 6th year. If the information about these 2 years is not with us, we cannot make any comparison. So in this particular case, it is necessary to have information at least for the 7th year. But whoever framed the question is, say, a smart one. He has given 2 more years, information of 2 more years. What exact conclusion can we derive and why? The conclusion can be this particular asset we should replace at the end of the 6th year, or say before starting the use for the 7th year. Why? The first reason is the average total cost is the lowest at the end of the 6th year. Number 2, from the 7th year, the annual running cost starts, or rather the annual running cost exceeds the lowest possible average total cost. There are 2 things. First, the least average total cost for a year, and another is the annual estimated running cost exceeds that lowest cost or that average total cost. What criteria should we use? So far as such type of questions in the examination is concerned, just say take the decision only on the basis of the least average total cost, because in examinations we can have the information only that is provided in the question. It is not, and another thing is all are imaginary questions. Otherwise, the theorem, rather second theorem is, as and when the running cost, annual running cost exceeds the average total cost, we have to replace the machine. That is also a logical thing. And number 2, remember the diminishing law of return. The average total cost is lowest at a particular, say, end of particular year. It is advisable to replace the asset at the end of that year. But in case of, say, on the basis of my experience of, say, solving and checking many questions of the exam in the examination papers, you first remember that in the year or at the end of the year where the average total cost is the lowest, go for replacement. That means even if in the imaginary questions asked in the examination, this cost, say, is less than or equal to this average total cost, you can select this year for the purpose of replacement of the asset. In the next few lectures, we are again going to discuss the same point with different kinds of cases. The information in the cases will be given in different way. That's it for now. This was the most simple case, just starting point of the chapter. I hope you also have understood some basics of the replacement decision. That's it. Thank you very much.